set the pace when I'm running. I always
Namaste Friends. So today is chapter 99, one short of 100. And in the last lecture, we saw about the statistical significance test. And I told you that it is going to be a two-part lecture. And yesterday was part one. So yesterday I did mention that in the tomorrow's lecture, we'll be covering all about test. And we left it in at a particular place. So today, lesson 99, chapter 9 in SciPython. This is part 2 of statistical test significance. Today we'll be seeing about all about the test. We saw about the one tail, two tail yesterday. Today we'll be seeing all about the test and also be seeing about the coding. And then I finally decided, starting from next chapter, which is 100, I'll be going towards Panda. I know I actually uploaded Panda lessons before, but I'm not totally convinced. And given the importance of Panda and Python in data analysis or even data engineering these days, where they can actually use PySpark or something, I'm thinking of Panda right now for quite some time, and then probably teach SQL so that you guys are up to date and can find any job in the market. Having said that, let's actually see this today's lecture. What is a t-test? The t-tests are used to determine if there is a significant difference between the means of two variables, and let us know if they belong to the same distribution. A distribution is, say, suppose there is a particular group, the distribution of top rank students, failures, low rank students. So the mean itself is more or less like an average. So the t-test allows it to actually find the difference between the means of two variables and actually let us know whether they actually belong to the same distribution, whether it belongs to this particular group. It is a two-tailed test. So it actually happens this thing and this thing, not a one tail. There is a function called t-test underscore indicator that takes two samples of the sample size and produces a tuple. If you see my Python earlier lecture, I would have given the tuple, tuple, and stuff of that nature, right? So this is the tuple of a t statistic and p value. All right. Let's actually take an example and let's actually given this, and this is for given values of v1 and v2 of the same distribution. I go here, I come here, I import numpy as mp. From SciPy.stats, I say import t-test because I'm going to be importing the t-test underscore indicator. I say this np.random.normal and np.random.normal. I say the resolution I want to find this. So it actually gives me the result. Okay, it gives me a statistical result and the p-value result. All right, fantastic. So if you want to return only one, only the p-value, use the p-value property. So here, if you see, if I actually take this and if I actually do this, the difference between these two is same thing you need to import. All these things are same. But here I have a statistics and a p-value, and here I say only the p-value. So let's see what it gives. It gives me only the p-value, and that is what it is. Fine. Now we saw the t-test. There's something called as a KS test. The KS test actually checks if the given values follows a distribution. Now say suppose we have like some high ranking students and they all get significantly high ranking, and we see whether they follow a distribution. Or if you're an aspiring sports star, if you're actually like running, they actually say like if the particular person runs in a particular second for a consecutive amount of time, which means they're actually qualified for Olympics. And then they take them to the next level to see how he is actually doing in the real-time scenario. Like zonals, state-wise, stuff of that nature. So this is to see whether you actually follow in the distribution. Just take it at a high level. The function takes a value to be tested, and the CDF has two parameters. It can either a string or a callable function. It can be used as a one tail or two tail. It is not necessarily a two tail like a t-test. It can be one tail or two tail. But by default, it is a two tail. All right. So like always, let's actually take this thing. So initially we saw a t-test. So here is a KS test. And then this normal, and then we actually run it. So the same thing. Instead of a t-test, it's a ks test. We only saw what a ks test is. So a statistical description here, there is only, you can't only do a p-value. Okay. So statistical description of data is, it is used to describe and present a foreign distribution, minimum maximum values, mean, variance, skewness, kurtosis. Okay. I remember studying all these things probably my 7th grade, 8th grade. I don't remember it right now. So if I actually have this, and if I actually take this, if I actually use this describe, and if I actually do this, it actually gives me everything: the minimum value, the maximum value, the mean, the variance, the skewness, the kurtosis. So there is a normality test, which is a skewness and kurtosis. It is based upon, the normality test is based upon the skewness and the kurtosis. Okay, very nice. So the normal test function returns a p-value for the null hypothesis, and x comes from the normal distribution. The skewness is a measure of symmetry in the data. For normal distribution, it is 0. It is negative if it is like, say, if it is like this, it is negative, it is skewed left. If it is positive, it is skewed right. Okay, so negative and positive. Negative is anything below 0. Positive is anything above 0. A kurtosis is a measure of whether the data is heavy or lightly tailed to the normal distribution. In the previous figure, I showed you this normal distribution. So I told you if it is heavy or lightly. A positive kurtosis is heavily tailed. Okay, it's a big, thick tail. A negative is lightly tailed. Think of a thin tail, very, very like a puppy's tail. Okay, or a positive is like a real dog's tail, which is like real thick. A puppy's tail is like very, very flimsy. So let's actually take this and let's actually see how it goes. I take this, I import my skew, I do my kurtosis, and then I do this. I get this value for my skew and my kurtosis. So this is negative, so which means this is negatively tailed and this is towards the other area. So this we actually figure it out, right? Now to see if the data comes from the normal distribution, I would actually take this. This is a normal test, and let me actually see this. So this is a statistics and this is a p-value. All right. This actually ends as the statistical test significance and the various tests which is actually used. I trust you would have actually seen my lecture. Probably enjoyed it. Probably understood it. If you have any questions, kindly contact me. I'll actually help you to the best of my abilities. Today concludes the Science Python. So we have finished a NumPython, we have finished a Science Python, and tomorrow we'll actually start the Panda once again. Okay, so this time a lot more in-depth and everything, because a Panda is going to be very important. Okay, Panda, I would say like 70% important, with probably a good 20 to 30% with NumPy and some basic Python comments. Okay, where you can be a good data analyst person. Like always, I would like to thank two persons. One is you for giving me a golden time, and the other is my wife Jayeshi following me to follow my passion. Till we see next time, thank you, take care, and cheers.